thing is to remember where you start and how you set your period. This all is from the unit circle. The cycle of the unit circle is 2 pi. So this is why we call it a periodic function, because it repeats itself every time it goes through that full circle, full period. And it just breaks it off into fourths. Halfway, 1/4 of the way, and 3/4 of the way. Each of those critical points always, no matter what your period is, if you remember that your end point is the full period, half period, fourth of period, 3/4 of period. And it doesn't matter if you're multiplying by fractions, you flip your reciprocals and go through all that. If you're doing a sine graph, remember sine starts at 0, it raises to 1, goes back to 0, and then it goes down to -1 and comes back up, and it just constantly oscillates like that.
There were 2 of mine where it's at 8 pi and 10 pi.
That's fine, because that was the period. And that's the only thing, what's changing here is that each one of these graphs works the same way, except that there's a scale factor thrown in it. Your scale factor for your period, for the B value, lengthens the period or shortens the period of how fast it oscillates through. The amplitude, the height at which it rises or drops, is just your A value. Later on today, we'll talk about a negative A value. So instead of, for a sine value, instead of going up first, it's going to go down first. That's it. We had it in there because I was just kind of showing you guys what's going to happen. You didn't have any homework problems like that. But we're going to have negative, it just goes a different direction. Yes, sir?
When are we learning HK?
Today. In about 5-6 minutes.
Sines look like this and the cosines just look like that.
Cosine is actually a shifted sine graph, pi over 2.
I'm sure we'll understand that.
What's up?
So if the B value is like 1/4 pi, it just becomes 8 pi, it doesn't become 8 pi squared.
No. No, because remember, if you're looking at, which one is that?
It's 41.
If you're looking at one like 41, so far today I've only really had to do like one of these examples, and everybody was kind of flying through these. Remember, list out what you know, what your A is, 1/2. That means your amplitude is 1/2. Your B value is pi over 4. So your period will becomes 2 pi divided by pi over 4, which is 8. Because the pi's drop out, you multiply by the reciprocal. And that's okay. You don't have to have a pi in it. It's no big deal. All right. When you go to graph this, then you just mark out what you know. Well, 8's at the tail. Halfway in is 4. Halfway in is 2. In between here is 6.
I'll be crumpled up a piece of paper and I'll throw it in the recycling bin, and that went in the like 1-inch space, which would be the right recycling bin in the wall.
Stick to organizational skills.
Ball is like.
And remember, your graphs don't have to be marked out and walked out, spaced out perfectly. I had someone ask me, why do all my graphs look the same? They should. You're scaling it differently on your grid. That's it. Doesn't have to be perfectly matched out to what you're used to regular graphics. That's why I don't use graph paper. So, sine starts at 0, goes to your amplitude.
I use a graph paper.
Well, you're awesome.
I know I am. I don't need you to tell me.
I just did. And that's it. Okay? Yes, ma'am?
There was in the one we had to match the graph.
There was a tangent one in there. That was my fault. When I listed those out real quick, I skipped the tangent one. So which one was not like the others?
C or F.
It was one that was going like this?
Yeah.
Or like this?
Yeah.
Those are the dance moves. You want to do dance moves? Tomorrow. I usually do sines and cosines first because they're very easy. Tangents kind of a weird ball. Yes, ma'am.
Okay, this may be a really dumb question.
No such thing.
But are they all supposed to be in like separated in fourths?
Yeah.
Okay.
Mhm.
I was just making sure because there was one where it was like it ended up being like a third or like 1/5 or something. And I was
And that's okay. If the fractions work out like that, it's fine. It's not a big deal.
I just wanted to make sure I did it.
Yeah. No, that's fine. Is there any of the others you want to look at all, or you want to just jump right into shifts?
Jump right into it.
Sure.
All right. Make sure your names are on that. Send it up. We'll go into the shifts. funny. Thank you, sir.
We gang sign.
Yeah, I did that earlier.
That's actually like.
Did you see that already?
I
Yeah.
don't think Thomas.
Our third hour gets like to pick on him a lot because of that look in the paper. They go, "Ooh." What is it? What is the weeping man or something? Screaming man. That's what it kind of looks like. The scream. But you know what I'm talking about.
Yeah,
What is it? Van Gogh or
I
something?
know.
Yeah. It's kind of easy to do that.
Yeah. You would know.
You guys all know what I'm talking about.
I actually really did.
Anyway, so what we're going to go into
I'm
today
always crying.
is translations. Once again, we're going back to A, H, and K. You don't need to write all this out because you already know what A, B, H, and K stand for. In trig functions, your A is your amplitude. Your B value works for your period. Your H is always your horizontal shift. And your K is your vertical shift. It's the same thing as what we've done anytime we've ever had H's and K. What's going to be a little bit different here now is that if your A value happens to be negative, it just means instead of rising to start, it goes down first. That's all. It's the only thing. Your amplitude is found by an absolute value, just like it was before. And it's just a matter of using a little bit of foreshadowing when you're writing out and starting to scale your graph. If you should make your x-axis a little bit longer, should you lower down a y-axis if it's being shifted up or down. And after you do a few of these, it's pretty easy to get the idea of where you're going to wind up with your final shift. When I do shifted graphs, I always list out my ordered pairs for my parent function and then my shifted function. So we're going to have two graphs on all of these, and we're still not using calculators. Yes, sir?
Why in all of the formulas for graphing stuff, why is it always minus h?
Because it's the distance. Remember when we measure distances, you're taking the one, subtract the other? It's how much is it then moved. That's all.
Alright.
Okay. It builds out of the distance formula, which is effective.
So if A is negative, you start down.
Yeah. Yep, that's it. That's all it is. So let's just go right into a couple examples here. What do you mean?
You said the distance formula, which
Your H is
all of geometry, which
Yes.
is trigonometry.
Yes. It all builds back. It's crazy. Hi, how are you? Good. Good to see you. I don't know who they are, but they know you. So we have y equals -2 plus 3 times the sine of 4x. First thing we're going to do is list out A, B, H, K. So what's A? So what's your amplitude? Good. What's your B value? So what's your period?
Wait, that's the -2.
What's your H? 0. Your H will always be within parentheses. Since there's no parentheses, there's no H, which means there's no horizontal shift. And then your K value is the -2. This book tends to put the K value sometimes in front or sometimes in the back, just to annoy you.
I don't think that's very
Oh, I'll write it out.
They just
Wait, why is the key in the front?
Speak up.
Oh, part of the cosine.
Yeah. And it's the same thing for cosine, just with cosine. Okay. So when we do this, again, we just start by marking it out. In this case, the only shift that I have to deal with is I'm going to move this one down 2. So what I'm going to do, instead of putting my line kind of in the middle, I'm just going to put it up a little bit higher. So that way my y-axis is a little bit lower. That way there's space. Because a lot of you guys, when you start doing your graphs, you do your graphs directly underneath your work. Well, if you have a shift that's rising up, you're going to run into your work. So just use paper. It's cheap. Mark out your period. Well, put it out at the end as pi over 2. So what's half of a half? What's after that? And what's 3/4 of a half? 3 pi over 8. So there's your ordered pairs. There's your critical values for the function. It's a sine graph, so sine starts where?
0.
And it rises to the amplitude. So it starts at 0, amplitude, 0, opposite amplitude, 0. What do you think we connect them with? Connect them with dots, because it's a parent function. Now remember when we did natural logs and exponential graphs and everything? When we had our parent function, then we listed out what we're going to do to our ordered pairs with our h and k. If you do the same thing here, it's going to be really easy to see how you're going to add your fractions. Because this is the worst thing that'll happen. You'll have some fractions that add together. So our shift, there's no x shift, because it's 0. But my y shift is going to be y minus 2. So my original is just some x and y value. And I list them. 0, 0. Pi over 8. 3. Pi over 4. 0. 3 pi over 8. Negative 3. And last pi over 2. Back to 0. My hands. Pi over 8. Yeah. It's tough when I'm writing sideways. I was only ambidextrous. So this will be at 0, negative 2. This is tough. Pi over 8. Couldn't get away from the buffet. And 1.
Oh, no, I get it.
Pi over 4. And negative 2. 3 pi over 8. And negative
Honestly, 2 is good.
5.
Pi over 2.
And then pi over 2. And negative 2. That's a lot harder to write with a different hand.
I just noticed that you were writing with your left hand, and I was like, has he always done that? Like, I don't want to point it out in case everyone else has noticed, but I have it through the whole year.
No. Because if I was standing here filling all this in, I'd be writing in your way, so I tried to write over here so you can see
So
those.
you're in my way?
For the first time all year.
It's just you.
I wrote it on the other side.
What's that?
I wrote it on the other side.
I could have.
You could have written it from
That
below.
would have been a little.
Wow.
Stares off in the distance.
0, negative 2.
Lazy.
Yeah.
Yeah, see,
And then you're a lot of talk.
that was some big talk you got going on.
What is the line of top gun? Your mouth is writing checks, your body can't cash.
Let's go on Tom Hanks, not Tom Hanks, but
Yeah, Tom
Tom
Cruise.
Cruise. No, Tom Cruise.
You screw up just this much, and I'll have you flying in a cargo plane full of rubber dog out of Hong Kong. That's how you write these things out, guys. It is that explicit, okay? There's really no curveball to any of this. There's no...
There is a curve. I was about to say, there are a couple curves, but it takes me like 10
What's that?
minutes to irritate this over me.
Because my shift was moving everything down. So let's try a different one.
Come on.
Let's do this. Let's give this a negative a value, and let's tack on a k value. So let's roll the whole shebang into one problem. So we have y equals negative 2 cosine of 2/3 times the quantity x minus pi over 4 plus 3. That just sounds awful. But list out what you know. A, B, H, K. What's your A value? So your A value is negative 2. So that means your amplitude is what? 2. Good. Remember, your amplitude is always the absolute value. Okay. Your B value is 2/3. So that means my period is going to be 2 pi divided by 2/3, which is 3 pi. Very good. My H is it positive or negative?
Positive. I learned that.
Positive pi over 4.
It took us so long to learn.
And my K value is 3. So this one's going to have a shift to the right and up. So what I'm going to do when I go to graph this, I'm going to start my x-axis a little bit lower than I would normally, because I'm going to have to raise it up, because all of my work is up here. So I'll probably put it here. And I'll make it a little bit longer off to the side as well. Now all I have to do is mark out my 3 pi like I would normally. Instead of going all the way out to the end, I'm going to bring it in a little bit, just put it about here. That way I have room to add stuff in later. What's half of 3?
3 pi over 2.
3 pi over 2. 3 pi over 4. And what goes there? Well, remember, it's 3/4. So multiply 3/4 times 3, do you get it? 9/4. Very good. Our A value is negative 2. Cosine starts at your A value. So in this case, cosine starts where? Negative 2. And then it just oscillates through the regular pattern. Negative 2, 0, positive 2, 0, and negative 2. Dotted line. And now all I have to do is just add pi over 4 to the x values, or add 3, or excuse me, and add 3 to the y values. So what's 0 plus pi over 4? Pi over 4.
It's 3 by negative 2. Not 3 by 0.
Oh, sorry. Thank you. So you're at pi over 4, and then what is negative 2 plus 3? 1. 3/4. Oh, sorry. So book it. Oh, sorry, I didn't realize I was going that fast.
I just can't.
You're probably not, I just think.
Yeah.
No, it's. I'm sorry. I'll slow down. No big deal. We have plenty of time. Tick-tock, tick-tock.
But see, then we told him we're not ready for the test, and he's like, this is an honors class.
This is a lot easier than what we were working on.
True.
What you guys just did was really hard.
Yeah, but that doesn't make sense though. So you're saying we can spend more time on the easy stuff, but we have to rush through the hard stuff?
We didn't rush through the hard stuff. We spent over a week in one section. We spent 4 days in this section before that. We spent
That
plenty
was
of
a
time.
long section.
We spent well over a month on that stuff. It was
That
not.
was difficult stuff.
So is the next one high?
Thank you for getting back on track. Yeah, because it's 3/4 plus a fourth, so it just gives me, pi. Okay.
Yeah, I did.
When I have 3 pi over 2, remember I'm working with fractions. I have to have a common denominator, so it's the same thing as 6 pi over 4. So you get, and then 2 plus 3 is. Remember, I'm adding to both the x and the y values. Now, that's what. This is 6 pi over 4. 6/4 plus 1/4 is 7/4.
Oh.
Then I have 9 pi over 4, add a fourth, you get 10/4, which is 5 halves. And 3. And then 3 and a fourth becomes 13 pi over 4.
Yeah, it does.
And that's 1. So what's nice about doing shifted trig graphs is that you're doing basically all of your work within the ordered pairs. You're adding, subtracting, and whatnot. Because when you go to place them, you know that this point's got to move to the right. Well, the new spot's going to be at pi over 4. Does it have to be perfectly positioned between 0 and 3 pi over 4? No. As long as you got a tick mark there with the label, it's not a big deal. It's close enough. Because what you're doing is you're doing the actual work of the problem, listing in the ordered pair. Here you're just given a visual representation of what you just did. Okay? The work is the ordered pairs. The visual is the graph. And that's why I ask you guys to always list your ordered pairs when you're doing this. Because now it's just a matter of resetting it. Pi over 4 and 1. We're going to go up. 3, 4, and 5. The next one is at pi and 3. 7 pi over 4 and 5. And here's your shift. Now, whatever. Because your graphs might look like junk, but your ordered pairs are right.
That sounds like an motivational
Yeah.
It's on the inside.
Should it be like a cat hanging onto a string at the same time?
Yeah, that's.
It's the effort that counts. It's the work.
That was from
It's
history.
the work. Get it? Like the math.
Not horribly scary, I'm hoping, right? It takes a little bit of space, but it shouldn't be bad. Okay.
Excuse me, there's more than all four.
Holding, waiting, sorry.
How long do you think if I don't take this? You're gonna call me out.
No, Julie's really tempted, but there's like
Oh, you
tissue.
can just put this up before you go.
No, then I have to make it up 30.
It's just 4x plus pi that it just kind of brought a little line in there. This might be kind of like the worst case scenario when you're setting up a problem. But you're going to see real quick what happens here. The generic form of our problems here is always a sine b times the quantity x minus h. notice what happens here. Inside the parentheses, the x value has a coefficient. You got to get it out of there. What do you do?
We got a 4.
Correct. This really, what happens a lot of times is they're going to hide the b value on the interior of the parentheses, so you have to factor it out. So when you do that, you wind up with 2 plus 3 sine 4 x plus pi over 4. It's not 12 sine because see how the 4 was stored inside the parentheses? The 3 is the a value because it's in front of the sign. The b value wasn't there until I took it out of the parentheses. No, remember what's happening here is that the a value, which is 3, tells you how high up it's going to go. That b value of 4 messes with the frequency. It's messing with messing with the period of how long it takes it to cycle through. They're two different things. They're two different scales, if you will. All right. So as you plow through one like this, it's the same thing, guys. Where you have your a of 3, which means your amplitude is 3. Your b is 4, so your period is 2. H. Very good. And K. The opposite part. Now I know that I'm going to be moving things to the left, pi over 4. So when I go to start my stuff, I'll put my y-axis a little bit more over. I probably should have lowered that. And since my amplitude is 2, or excuse me, my shift up is 2, I'll make the top part a little bit taller. Gotcha.
No, I figured it out.
All right. So all I'm doing there is I'm working ahead knowing that, okay, my graph is going to have this move to the left. It's going to be up a little bit higher. So I'm just setting my stuff on my paper a little bit more to have a little bit more space. That's all it is. Mark out your period like you would normally. Here we have a pi over 2. We can put it all the way at the end because it's got to move to the left. By now, you're going to get kind of used to the working with a pi over 2 period. Hopefully you got those for your marks. Pi over 8, pi over 4, 3 pi over 8, and then pi over 2. It's a sine graph, so where does this start? 0. 0, then it goes up to. So it goes up 3, so 0, 3, 0. This is we got it drawn. Still. And now you just have to be careful when you're adding your fractions. In this case, we're subtracting. So you have 1/8 minus 1/4. That's the same as saying 1/8 minus 2/8, which is what? Negative 1/8. I skipped the first one by mistake. That was easy. It's negative pi over 4 and 2. What's 3 plus 2? See? You don't need a calculator. Pi over 4 minus pi over 4. What's that?
It's hard to write in
I'm s-
words.
sorry? Then you have 3/8, basically minus 2/8. So what do you get? 1/8.
These ones, do you ever want y-intercept?
Oh, wait, well, yeah, take one. Why is, no. Really don't need it. And then, last, we have, pi over 4 minus a fourth is what? 4. That's 4. And then we're back at 2.
I do that a lot.
It's always making sure,
Takes
because
me a
this is 2 quarters, take away a quarter, and you're left with?
Well, I did just
A
do
quarter.
it for a second. I don't know what it was. I was like, should it be 3 pi over 2?
Speaking of quarters, what do you think would happen if Walmart made you pay a quarter for your shopping cart like Aldi does?
But you
Like,
get it
you
back.
get a quarter back at all.
Well, I know, but then you'd have, but then you'd actually, you wouldn't have shopping carts all over the parking lot all the time.
Money can go to a true car.
But don't you get your quarter back?
You do, but you have to bring the cart back.
I wish they would.
I would too.
That'd make driving through the parking lot a lot easier.
Right on.
Like, I
But you
have
don't
trouble
know.
driving on regular roads right now.
You would come back.
The last thing I need is a car.
No, that's like a cost for being lazy. If you want to be lazy, you just lose 20%.
So then you go and mark off your stuff. Now, hey guys, obviously in this case, we know that we're gonna have this value, this one's already marked on here. We're already, those 3 values are on our graph. So all I have to do is put on a negative pi over 8, and then a negative pi over 4, because these are already there. So negative pi over 4 and 2. Negative pi over 8 and 5. 0 and 2. Pi over 8, negative 1. And pi over 4, 2. There we go.
What is,
Yes, sir.
if we use like sine graphs and stuff to find like, you said like sound waves, what does shifting help with?
But the sound, if you think about sound waves, each pitch has a different frequency. Okay? If you watch like a tuning fork, is it called an oscilloscope? Is that right? Physics people help me. Is it an oscilloscope? We're going to call it an oscilloscope.
Okay.
And what those things do is they measure the signs and how fast the frequency is, how fast is something that vibrating. And then as it vibrates quicker, with a shorter length, the pitch is higher.
Wait, do you really force it?
So sounds are all just frequencies and periods of how fast something is vibrating as it goes, as it's broadcast across the air.
I'm just wondering,
Hold on,
what
when
does
is
the
that
shift
ever
help with
shifted?
though?
The shift helps it, the shift tells you, the shifting of it is, it's gonna give you pitch.
I don't know what pitch means, so I'm just.
Do you remember tolerance class where we hit the 46? Okay, that's really good.
This should have been known that was.
I think I had any other. All right, let me get some homework. Yeah.
We got you. I don't know if that's your best.
And then we'll go off and do the, we'll do tangent stuff tomorrow. Tangents are very similar. Their periods are a little bit weirder, which means their fractions tend to be a little bit weirder, but it really isn't going to be that bad. You did. Yep. Tangent, because can you divide by 0? Because what happens at 90 degrees on a tangent? You have sine over cosine. Cosine is 0, so it's 1 over 0, so it's undefined. And it happens again at 3 pi over 2. So you have asymptotes. So your tangent function is, it repeats itself every pi.
Are there any of those we aren't grasping?
What's that?
Are there any of those we're not grasping?
No, you're doing, those are all sides and cosines, sir. Those are all sides, we'll do, I'm going to group tangents together tomorrow.
What if your rest was failed?
The last ones you're writing the equation given
Yeah,
value.
wrestlers.
You're given shift, write the equation. I didn't show you how to do that. Let's see if you can do it. Okay?
Wait, so are 36 and 42 involving shifts?
Yeah.